Good day, everyone. Now, we are discussing about nonparametric test. So, let's first define what is nonparametric test. Nonparametric tests are mathematical methods used in statistical hypothesis testing, which do not make assumptions about the frequency distribution of variables that are to be evaluated. And it is also sometimes called a distribution free test. For example, that the data comes from a normal distribution. That's compared to parametric test, which makes assumptions about a population's parameters. For example, the mean or standard deviation. When the word non-parametric is used in stats, it doesn't quite mean that you know nothing about the population. It usually means that you know the population data does not have a normal distribution. There are appropriate statistics to be used in non-parametric test. So let's first know what is Wilcoxon signed rank test. The Wilcoxon signed rank test is a non-parametric test. The Wilcoxon signed rank test should be used if the differences between pairs of data are non-normally distributed. Example: Math 12, 7, 5, 4, 6, 11, 10. Science 2, 8, 9, 6, 1, and 4, and 3. We have now the table, the section, the first column, so we have 1 to 7. The math, we have 12, 7, 5, 4, 6, 11, and 10. And from the science column, we have the 2, 8, 9, 6, 1, 4, and 3. So the step 1, let's subtract science from math to get the differences of the two. So 2 minus 12 is equal to 10, 8 minus 7 is equal to negative 1, 9 minus 5 is equal to negative 4, 6 minus 4 is equal to negative 2, 1 minus 6 is equal to 5, 4 minus 11 is equal to 7, then 3 minus 10 is equal to 7. Then the step 2, place the differences in order from column 2 in the picture below and then rank them. Ignore the sign when placing in rank order. We have the first column, we have the rank 1 to 7. This is in order. So rank 1, we have the 1. Rank 2, we have 2. Rank 3, we have 4. Rank 4, we have 5. Rank 5, we have 7. Rank 6, we have 7. Then rank 7, we have 10. So the step 3, make a third column and note the sign of the difference. So as you can notice, we ignored the sign from step 2. So sign, so 1 is negative, 2 is negative, 4 is negative, 5 is positive, 7 is positive, 7 is positive, and 10 is positive. And now, let's come up to the next two steps in calculating the Wilcoxon signed rank sums. We have the step 4. It is where to calculate the sum of the ranks of the negative differences, the ones that we ignored the negative sign in step 3 chart, which is this one. So we are adding up the ranks here, not the actual differences. So from this table, we have to get those negative sign, then add all of them. So we have 1, 2, and 4. This one. 1 plus 4 plus 2 is equal to 7. And now, go to step 5. These were to calculate the sum of the ranks of the positive differences, the ones with the positive sign in the step 3 chart. So from this table, we have to get all the positive sign, then add all of them. We have the 5, 7, 7, and 10. And now, 5 plus 7 plus 7 plus 10 is equal to 29. So the next thing that we do is using the normal approximation with Wilcoxon signed ranks. If the number of observations or pairs n times n plus 1 divided by 2 is greater than 20, you can use a normal approximation. This set of data meets this requirement. 7 times 7 plus 1 divided by 2 is equal to 28. Then, we are going to use the following formula for the mean, which is n times n plus 1 divided by 4. And the next, we have to use the following formula for standard deviation, which is square root of n times n plus 1 times 2n plus 1 divided by 24. So that we have two tied ranks, we must reduce the standard deviation by t cubed minus t divided by 48. So, there are two tied ranks, which is 5.5 plus 5.5. We have to reduce standard deviation by 8 minus 2 divided by 48 is equal to 0.125. So overall, this gives us the score of z is equal to 7 minus 7 times 8 divided by 4 divided by square root of 7 times 8 times 15 divided by 24 minus 0.125. Then z is equal to 7 minus 14, which is 7 times 8 divided by 4 is equal to 14. Then divided by square root of 840 divided by 24, which is 7 times 8 times 15 is equal to 840. Then minus 0.125. Then z is equal to negative 7, which is the result between the differences of 7 minus 14 is equal to negative 7 divided by 35 minus 0.125. So the result of 35 is when 840 divided by 24, the result is 35. Then negative 7 divided by square root of 35 minus 0.125 is equal to negative 1.21. So the next non-parametric test is Spearman's rank correlation. Spearman's rank correlation is a non-parametric measure of the correlation that uses the rank of observations in its calculation, rather than the original numeric values. It measures the monotonic relationship between variables x and y. So the example, there are 7 sections on grade 9 class. Math and English has a lot of students get the highest score. There are listed numbers of students get the high score. From math, we have 12, 7, 5, 4, 6, 11, and 10. From English, we have 10, 8, 6, 3, 5, 12, and 9. From the step 1, we have to find the ranks for each individual subject. And I use the rank by hand. Then order the scores from the greatest to the smallest. Assign the rank 1 to the highest score and 2 to the next highest, and so on. So from the highest, from the math column, we had 12, the first one. Then the second is the 11, third is 10, fourth is 7, fifth is 6, sixth is 5, then 4 is 7. So from the rank in English, the first rank is 12, which is this one, the first one. The second is 10. The third one is 9. The fourth one is 8. The fifth one is 6. The sixth one is 5. And the seventh is 3. From step 2, we add a column for D to our data. The D is the difference between the two ranks. So 1 minus 2 is equal to negative 1. 4 minus 4 is equal to 0. 6 minus 5 is equal to 1. 7 minus 7 is equal to 0. 5 minus 6 is equal to negative 1. 2 minus 1 is equal to 1. Then 3 minus 3 is equal to 0. So the last column, we have the D squared. So negative 1 times negative 1 is equal to 1. 0 is 0. 1 times 1 is equal to 1. 0 times 0 is equal to 0. Negative 1. So 1, then 1, 1. 0 and 0. So from step 4, we have to sum up or add up all the D squared values. So we have 1, 0, 1, 0, 1, 1, and 0. So like this, summation of D squared is equal to 1 plus 0 plus 1 plus 0 plus 1 plus 1 plus 0 is equal to 4. So let's go to step 5. We have the formula P is equal to 1 minus 6 summation of D squared over N times N squared minus 1 and now we must substitute P is equal to 1 minus 6 times the summation of D squared is 4. So 6 times 4. Then all over the number which is 1, 2, 3, 4, 5, 6, 7. You have 7. Then so N squared, you have to square the 7, which is this, minus 1. Then now 6 times 4 is equal to 24 divided by 7 times 7 squared minus 1 is 336. Then P is equal to 1 minus 24 divided by 336. And now we have P is equal to 1 minus, so 24 divided by 336 is equal to 0.07. Then P is equal to 1 minus 0.07 is equal to 0.93. This is the Spearman's rank correlation for this set of data, which is 0.93.